Hi guys, I realized yesterday after class that we hadn't talked about how to figure out which of your percent changes of mass went with which molarities of the sucrose solution that you used. I know I talked about this with a couple of the groups, but not all of them. So I wanted to go over my thinking to help you in deciding what masses went with which molarities, just in case you haven't done that already. So I just made up some fake data over here. And so I said, well, let's say that these are our percent changes of mass. And I also know that my molarities of sucrose were these four that I have to choose from. And you did know at least what your percent change of mass was for your potato cores that were in water, which has a molarity of 0 because there's no solutes in it. So I know that my potato cores in my water will gain weight because there are solutes inside my potato core cells. So the water is going to go from the beaker into my cells because my cells are hypertonic and water follows the solutes to try to make them less concentrated. Okay, so that one I know. I need to figure out the rest. Well, I know that as I start increasing my molarity, then I should gain a little bit less mass. And I know this because as my amount of solutes outside of the water starts to increase, it will get closer to the amount of solutes that I have inside of my potato core. So let's try to figure out what my my percent change of mass will be for my 0.2 sucrose solution that my cells were in. So I think, 0.2 is kind of close to water. So I think 0.2 should be the next greatest gain in mass. So my next greatest after a 26% gain would be a 20% gain. So I think that this should go to my 0.2. Now as I try to figure out what percent mass goes with the 0.4 molarity solution, I think, okay, so it's going to get probably a little closer to the molarity of my potato core cells. So I'm going to have a slightly less percent change of mass than from my 0.2. So I'm going to go to my next highest percent change of mass, which is 15%. So I know that this needs to go to my 0.4 molarity. Okay, now something you need to understand is that as long as the potato core's molarity of solutes inside the cells is greater than the solution's molarity, then your potato core is going to gain weight because it's hypertonic to the solution that it's in. Now, when we get to percent changes of mass that are negative, so it's lost weight, now I know I've switched over, and now I know that I'm in a solution that has a greater molarity than my cells do. So 0.6 is a little less concentrated than 0.8, so that will lose a little less weight than in the 0.8. So I'm going to go with the smaller negative percent change, so that's negative 32, and that one needs to go to the 0.6 molarity. Now by default, I know that my negative 54% change in mass needs to go to the 0.8 molarity, and that's because inside the cell there was a lot less solute concentration than outside in my 0.8 molarity sucrose solution. Something else that I want to make sure that you understand is that where your percent change in mass flips from a positive gain to a loss, your molarity of your potato core cells is going to be somewhere between there. So when I look at this data, I see that the change happened when it went from a zero point 0.4 molarity to a zero point 0.6 molarity. That's where I went from a 15% gain to a 32% loss. So I know when I graph it,